define the domain of functions. So if you remember, the domain is the set of all x, the set of all x values, such that what? F of x exists. The domain of f of x consists of all x such that f of x exists. We said we have two main cases for which f of x does not exist. If you remember, dividing by 0. Dividing by 0 does not exist. If we have any number dividing by 0, this does not exist. This is unreal. Also, if we have radical of negative number. So if you are given the rule of f of x, you have to avoid these cases. Now, if you have p of x over q of x, then you have to solve q of x does not equal to 0. The denominator should not be 0. You have to exclude all values of x for which q of x is 0. So, in other words, exclude all the zeros of the denominator. Okay, so exclude all the zeros of the denominator from the real one. So this is the first case. This one. The second case, if we have radical of certain function. So I get something like this. What I should do, I should solve p of x to be greater or equal to 0. Yes. I have to solve p of x greater or equal to 0. In this case, I'll get what? Get the domain of f of x. So if we have this form, exclude the zeros for the denominator. If you have this form, you have to exclude all negative values. You have to exclude all negative values. Okay, let us have an example dealing with these cases. So let us assume f of x equals to radical of 6 minus 2x. And I would like to find the domain of this function. What is the domain of this function? Of f of x. So as you see, we have the second case, radical of expression. radical expression, I have to what? To exclude all negative numbers. So I have to what? Solve this greater or equal to what? To 0. After you solve this inequality, you get the domain of this function. How to solve this inequality? As I told you last time, it's simple as solving an equation. So just replace this greater than or less than or equal or whatever, replaced by what? By equals to. So solve this equation. Solving this equation will give us what? Move 2x to the side. Divide by 3. Divide by 2, I'm sorry, 3. So x equals to 3. Do you have to include 3 in my solution? Yes, you have to. Why? Because we have equals 2 in this case. So the solution will be part of the real line, to the right or to the left of 3. Including 3. Why including? Because we have this equality. Okay, so now verify which set, this or this, satisfying this inequality. 6 minus 2x greater or equal to 0. To see which set how you take the radical. It's already there. Who's asking? Nasser, it's already there. It's in the question. This is an example. If you have a radical, you have to what? You have to exclude all negative numbers. So I have to require that 6 minus 2x is greater or equal to 0. Solving inequality, we have just to replace this with equals to and solve the equation. Then choose the portion of the real line which will solve your inequality. How? Just pick a number to the left of 3, another number to the right of 3.
2 and 2.
2 and
2. Minus 2 and 2 and 4.
2 and 4. For example, x equal 4 to the right, x equal 4. And now ask yourself, does x equal 4 satisfy this inequality or not? How? Just replace x with 4. 2 times 4 is 8. 6 minus 8 minus 2.
Yeah.
Minus 2 greater or equal to 0?
No.
No. Minus 2, 6 minus 2 times 4. Is it greater or equal to 0? Is it?
No. No.
No. The question no. The answer is no. The answer is no, so you have to exclude all of these numbers.
Okay.
What about the other side? To the left of 3. What do you have on the left of 3? Less than 3.
2.
2. Replace x with 2. 6 minus 2 times 2 is greater or equal to 0. Is it true or false?
True.
True. 2 times 2 is 4. 6 minus 4, 2.
2.
Greater or equal to 0? Yes.
Yeah.
So you have to include this portion. So what's the domain of this function? The domain of this function starts at minus infinity and it's at 3.
Yes.
You include 3 and you exclude minus infinity. Why? Because minus infinity is not a real number. So the domain is
Three.
minus infinity to 3. If you want to write down the solution, it's already recorded. So.
Can we find it in Blackboard after, right?
Yes, you can. Just go to the recording. Go. Let me show you. Three, four, six. Go to your section. Go to online classes. Go to these. You see this? The menu.
Yeah.
Click on them. Go to recording. Hold.
Okay. Thank you.
Yes, sir.
So,
Yes.
can I have a pen?
Be careful.
Pen.
Pen.
Yes.
Yeah. Okay. All right. So let us have another example. Find the domain of x equals to 1 or 2x divided by 8 minus x squared minus 2x minus 8. Find the domain of this function. So which case do we have in this case? We have the first case, the fraction case. All what we need to do is what? Is to exclude all the zeros of what? Of the denominator. We don't want to divide by what? By 0. So I have to exclude all the zeros of this expression. So so exclude all x which satisfies or which satisfy this equation, x squared minus 2x minus 8. So you go to the real number and you exclude all of the roots of this equation. All the roots of this equation. How to solve this equation? You go to your calculator, mod 3.
X1 will be 4, X2 will be minus 2.
Yes, you're right.
Four and minus 2.
Mr.
Yes.
I want to ask you, the math, they deleted from my schedule. Why?
What?
On Sunday I was in the class, and now I don't have math. Why?
It's your schedule.
I didn't do anything. Like, why? Just now I arrived and joined, and it's not here. It was 4 and ma.
Go to downstairs to Khulud. Ask about Khulud.
Okay.
She's in charge of these things.
But can you check if my name is in the list?
Okay, yes, sure. All right, let us see name. Okay, so solving this equation, the x is 4 and x is -2. That's it. So if you substitute 4, you will end up with what? 16 minus 8 minus 8, 0. 2 times 4, 8 divided by 0. I don't want this value. If you substitute minus 2 squared, 4. Plus 4, 8. Minus 8, 0. So we divide it by 0 again. So I don't want this value. So these values will cause division by 0. So I have to exclude them out of the number. So the final answer, the domain is the whole real number excluding 4 and -2. Okay, we have to exclude 4 and -2 out of the domain. What's your name?
Ahmed Muhammad Ali.
Ahmed, you're saying you withdraw from the course.
Oh,
You label your name as withdraw.
so what I should do now?
Go to Khulud.
We got her and I don't see.
Okay.
Thank you.
So this is the domain of this function. What about if we combine both cases? If we have radical, but in the same time we have fraction, something like this. Take g of x equals to radical of x minus 2 divided by x minus 5. So you have to deal with both cases. Now we combine both cases. So how to find the domain of this function? You see, I have two conditions. I have to look to this expression. This expression must be greater or equal to 0, right? then I have to exclude all the zeros of the denominator. So go to the denominator. X minus 5 should not be a 0. So these conditions that I have to apply, right? Under this, it has to be greater or equal to 0. For the denominator, it has to be non-negative. Solve this, then combine. How to solve this one?
X equal to.
Yes, x minus 2 equals to 2, 0. X equals 2. And now take the red line, infinity minus infinity, and include 2. Which part I should pick? X minus 2 should be greater or equal to 0. All right, so pick a number to the left of 2. One number. 1. 1 minus 2. Minus 1. Minus 1 greater or equal to 0?
No.
No. So, no. What about an element to the right of 2? 3. 3 minus 2?
1.
1 greater or equal to 0? Yes. So this is the portion that I have to take. So this portion satisfies this equation. But still, you have to wait until what we, yes, until we deal with this condition. If x is not 5, if x minus 5 is not 0, move the 5 to the side. X is not what? 5. So, you see this? This is the portion which solves the first part, right? I have to exclude 5 out of it. So go to the 5, you see 5? This 5, you have to exclude 5. You have to exclude 5 out of the first set. So what's the final answer for the domain? The domain starts at 2, then to 5, then from 5 to what? To infinity. So the domain contains 2 segments. The domain starts at 2 to 5, then from 5 to what? To infinity. 2 intervals. At 2, it's closed, as you see. At 5, it's open. And at infinity, as you know, it's open all the time. That's all. This is the domain of this function. Now, out of this set, I cannot substitute any value. For example, it starts at 2. Can I substitute 0, for example? I can get a real number? No. Check 0 minus 2 minus 2. And the radical does not exist. You know? This is what I mean by what by domain. Okay, then they define the range in addition to domain. We'll deal with with extra examples on domain, but let us what? Differentiate between domain and range. Or before moving there, let me ask you an easy question. What's the domain of this? Find domain of h of x equals to 2 minus absolute value of x. Which one represent the domain of this function? Okay, who's saying A is the solution? I'm also saying D. Any other answers? Who's saying D? D. D. Any other answers? Two students saying D. 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 Any other answers? Okay, so we learned to exclude what the zeros of the denominator, right? And the negative and the radical, right? Does this function have radical?
No.
There's radical over there?
No.
No. What about fraction? Does it have a new denominator? No, so why excluding any real number? You don't have to exclude any real number. So the answer is what? All the real numbers. A. Because this function does not have f or h. X does not have radical nor denominator. So if the function does not have radical nor the domain is the whole real numbers. Now, out of graphs, how to determine the domain and the range. So, how to determine the domain and the range of a given function. So, given a relation defining y as a function of x, the domain is the set of all x in the function, and the range is the set of all y values in the function. So it means if you draw a vertical line and intersect the function, the curve, the curve of the function, then this x in the domain of x. Okay. If you draw a vertical line and this line does not intersect the curve of this function, then this value is not in the domain of f. For the range, you do the same, but with horizontal lines. Horizontal lines. If the horizontal line intersects the curve of f of x, then what? Then this value in the range. If not, then this value is not in the range of f of x.
Of X or of Y?
Let me. This is an example. So what you have to do to draw vertical lines. By the way, these ending, you see these. Yes. So it means you can extend the curve, which means that you can. Okay, so the function goes to infinity and minus infinity. Now, if you draw vertical lines to this function, start from here, for example. If you draw vertical line, you will intersect the function. So this x in the domain. The same here. Same here. The same here. Right? So you keep intersecting the function from minus infinity to what? To infinity. So this function has a domain from minus infinity to infinity.
Domain is minus 1.
The domain from minus infinity to infinity. Now, what about if we take horizontal lines to find the range? Let us check. If you draw vertical lines, horizontal lines, you see, you cannot, this line does not intersect the curve. Okay, right? This one does not intersect the curve. The next one also does not intersect the curve. The x-axis itself does not intersect the curve, which means 0 is not in the range of f of x. So where we start the range? When y equals to what? This is y equal 1, and it does not intersect the curve. We start at y equals to 2. You see this y equals 2, it intersects the curve at this point. This one. Okay. at this point. Then, if you go further up, y equals 3, you see this line intersects the curve in 2 points, not in only 1 point. Just it intersects, yes. Then keep going. All of these lines intersect the curve, right? Until what? Infinity. This, as I said, this line or this this segment, it goes up. So until infinity. So the range starts at y equals 0, ends at what? At positive infinity. So the domain, in this case, from minus infinity to infinity. The range from 2 to infinity. Okay, before taking example 18, I want to ask you a question.
Before I studied when line is touched with y, then will be.
Say what?
Before I studied when the line, the blue color of line, when it touches the y, this is the number of the red.
None what?
When the blue line.
Go to the board. Okay.
Or I studied when the blue line is touched here, then I write the number. Not from it.
No, you see, the lowest point for this curve at what y? At 2. So
The lowest number.
the range, yes.
Okay.
Okay. So the lowest y and the highest y. This is what we're looking for when we talk about range. For domain, we're looking for the farthest x to the left and farthest x to the right. Okay.
You didn't take the when you touch it.
No. This is intercept. This is an intercept. We studied this before, right? The intercept for this function is what? Is 3. And how many x-intercept does this function have? The y-intercept at 3, right?
Yes.
How many x-intercepts does this function have?
0, 0.
None. Excellent. No x-intercept for this function. Okay, now I want you to answer this one. About the domain of, say, this is y-axis. I have this parabola. What is the domain of this function and what is the range of this one?
0 and 2,
Okay.
and the domain is minus infinity to infinity.
So the range
It's 0 and 2.
range from 0 to 2.
No, 3.
Domain not the same from minus infinity to infinity. Are you convinced? Yes. Why? Because this goes forever down, the same here. So it goes this way. So if you keep drawing vertical lines, it intersects the curve. Matter of fact, the domain, I can get the domain if I put your pencil on the curve and keep tracking this curve. You see, you can go from minus infinity to infinity.
They both go down,
Yes, we're going forever.
both in minus.
Yes, so from minus infinity to infinity, this is our domain. Now the issue is what is the range. Where's the range?
0 and 2.
So your friend saying from 0 to 2. How about that? So what we should do, we should draw horizontal lines, right?
Yes.
We're going from minus infinity to infinity. This is for y, this is minus infinity. And this is infinity. So going from minus infinity,
From minus infinity to
it intersects the function.
Yeah.
We keep what intersecting the curve, right?
Yes.
This is from minus infinity to where? I have to go up.
Yeah.
You see, all of these lines intersect the curve
Yes. Till 3.
until 3. That's it. After that, if you draw a line, it will not intersect the curve. So the range from so this is y. This is our x. What is the domain and the range of this function? So let me give you option. Domain. which of these options describe what the domain and the range of the shown function? Hmm? A? We're saying A. A? So one vote for A. Also saying B.
B.
B?
If it will be dark, it will be this one.
Yes,
No problem.
close. You close it. If not, you open it.
Yes.
So which option?
B.
Huh?
B.
B?
No, it's C.
C?
No, wait.
B.
B? So who's saying A? A? Who said A? B? C? Excellent. The answer is A.
Because if it will be the dark, then it will be like this. Not bright.
Right. So draw vertical lines for this function. Vertical lines, you will not intersect the function before -2. Before and at -2. You do not intersect the function also at -2. Why? This is open. Open means it's not included. So I'm not going to include -2 in my solution. Afterwards, all the vertical lines will intersect the function. So the domain from -2 to infinity, but open at -2 because of this. Now what about the range? Take now what horizontal lines. You see, you not intersect the function below x-axis. Below x-axis, you will not intersect the function. The first horizontal line which will intersect the curve is the x-axis itself at y equals 0. This is the intersection point. Then afterwards, you will intersect the curve until infinity. So the range starts at this point, y equals 0, x-axis, y equals 0. At this point, y equals infinity, therefore the range from 0 to infinity, and we include the 0. Why? Because at 0, y equals 0, this is y equals 0, it touches the curve. So A is the correct answer. Yes. أقواس بس اللي إذا excluded or included. هاي included ولا لا؟ هاي excluded. This one is what is excluded. We have something like this. Like this line. And at the end, I did something like this. This means that we include this end. So in this case, we exclude the end. In this case, we include it. Okay, going back to the book or to the notes and solve the second example. Okay, this is an excellent example for what including and excluding. So what's the domain of this function? What's the range of this function?
Minus 10 will be the
Domain from
to a positive infinity.
what's the starting point? Starting at what?
Minus 10.
Minus 10?
Hmm.
This is what? Range or domain?
Domain.
Domain, okay. So your friend saying from minus 10 to infinity is the domain. So let us start drawing what vertical lines to this function and see. But this is infinitely, you can extend it to infinity, right? So drawing a line, it intersects this function. This vertical line also intersects the function. This one intersects the function. This one intersects the function. The same here, it intersects the function. After 0 also, it intersects the function.
Range will be minus 10.
So the domain from minus infinity to infinity, maybe we should exclude or include 0. I don't know. Now, do we have to include 0 or not? So let us what? Draw a vertical line at 0 carefully. Does this line intersect the curve of f of x or not? Does the vertical line, the red vertical line, intersect the curve or not? At what point, if it does, at what point this line intersect the curve? 0 and minus 1. Excellent. Yes, it intersects the curve. So we don't have a problem at 0. 0 is within the domain. So all the real numbers is within the domain. Matter of fact, f of 0 is minus 1. So exist. F of what? F of minus 1, minus 2, 2 point maybe 5. F of minus 2, 3. So I have the images for all the real numbers. So the domain from minus infinity to infinity. Now the problem for what? For range. What's the range of this function?
And infinity positive infinity.
What?
Minus 10 and infinity no, positive.
Minus infinity to 10.
Yes, infinity.
So minus 10 included or not? Okay. Your friend saying minus 10 to infinity. Do you agree or not? Let us start with what? With horizontal lines. So you see at y equals minus 12, I don't intersect the curve. At minus 11, same. There's no intersection with the curve. Y equals minus 10, yes, I intersect the curve. Okay, so go further up, I intersect. I keep intersecting. The same. I keep intersecting. I keep intersecting. I keep intersecting at this side. The what? The right side. the left side, I stopped intersecting, but it's all right. I'm saying if it intersect or not. I'm not saying how many points do we have in the intersection. So I keep intersect, I keep intersect, I keep intersect. Till what? Till infinity. So your friend is right. From -10 to infinity, and we include -10. Why? At -10, this is the intersection. This is the point of intersection. Right? Okay. Now we have a third example from the book. And let me give you multiple choice. Uh, okay, what's the domain of this function?
I think it's B.
First, let us concentrate on domain. Domain of f. What's the domain of f? Is it like in A and B or in C and D? C or D? So minus infinity to 4 or union of two segments? Huh?
A and B.
A and B, yes, you're right. So the domain should look like from minus infinity to 4 only.
Yes.
there's no need to split the domain into two segments. Why? Because if you draw vertical lines, you see it intersect the function f, it intersect the function f, intersect the function f, the y-axis intersect the function f. One which has a problem, you might think there's a problem at one, but there's no problem at all, because this will intersect the curve at this point. F of 1 is 2. F of 1 is 2. So 1 is in the domain of f. And keep going. Going to where? Not to infinity, to x equal 4. So from minus infinity to what? To 4. This is the domain. What about the range? So now we're ruling out C and D.
The range is
So now the range, either 2 to 8 or 2 to 8 union singleton 1. So 1 in addition to 2 and 8.
yes.
This means no, 1 is not in the range. Which one is true?
It's B.
B. Yes, you're right. B is correct. Why? The range, this horizontal line does not intersect the function. The same here. What the x-axis does not intersect the curve of f of x.
Right.
Now, if you draw a line at 1, it will intersect the function, right?
Yes.
In how many points? In infinitely many.
Yeah.
These are infinitely many points. So y equals 1 is in the range. But just go up a little bit above 1, it will not be in the range. Go up a little bit, it will not be in the range. We go back to the range at y equals what? At y equals 2. And you will stay inside the range until 8. So you have to include y equals 1 to the interval from 2 to 8. So this is the range of this function. So the domain from minus infinity to 4, including 4. The range is from 2 to 8. One in addition to 2 and 8. The next example and the last example. This is misleading a little bit. You have to be cautious.
For positive infinity range,
4 to infinity is the range.
or not infinity, very simple. Positive.
4 to minus infinity.
Turn down,
Okay.
then minus infinity.
So Nasser saying the domain from minus 2 to infinity.
Yes.
Do you agree?
Yes.
Yes. So the domain from minus infinity, no, minus 2 to infinity. Yes, correct. Why? Because just you have to extend this line. So whenever you draw a vertical line, it will start, of course, not this line. I'm not talking about this line. I'm talking about this one at minus 2.
Yeah.
Then afterwards, it will keep intersecting what? the curve. So from -2 to infinity is the domain. What about the range? The range,
4 to
we give you two options. From -1 to -1 to 4. This is option 1, option A, this is A. B, from -infinity to 4. Which one do you think? Which one do you think is the correct one?
Minus infinity to 4.
It's B.
-infinity to 4 or -1 to 4? Huh?
B.
B? No, -1. This is -1. -1 to 4, yes, -1 to 4. -1 to 4.
But we start from up.
-1 to 4. Is it the range or from -infinity to 4?
It's better. Yeah.
A little bit misleading, right? No, this is B is the correct answer. Why? Because you have to extend this.
We start from up.
So when you draw horizontal lines, you draw using this extension. Now, when you draw the horizontal lines, of course, you'll not intersect the function here, but you'll start intersecting the function at y equals 4. And underneath. So 3, 2, 1. And under -1 because of this extension. So the range from -infinity to 4. It's good to remember to mention, if you write like this, you will get 0. I saw some student writing like this. There's no interval in math with the right-hand side less than the left-hand side. This set is empty. The empty set. Okay, so all the time, keep in your mind to put what? The lowest, then the highest. Okay, the minimum, then the maximum. All right, if you go back to the recording, try to solve these. They ask us to find the domain and the range of this function. This is very easy question because they're given us as points. So you have 5 points. Just write the coordinates of this point. You can guess what's the domain and the range. The domain is -4, -2, 0, 3, and 4. This is the domain. The range, -3, 0, 1, and 5. This one, we just solve similar exercises to it. Then they ask us to find the domain of these functions. You see, B and D, you can give the domain by sight without solving anything. Why? What is the domain of G and P? What are the domains of G and P? Do you have an issue about G and P? Remember, when you have to exclude values out of function, you have to have a denominator equals to 0 or negative radical, right? We don't have. G is x squared over 5. The denominator will not be 0 at any x. Right? So the domain of G is minus infinity to infinity. The same for P. P we don't have a denominator, nor what? Nor a radical. So the domain for B and D are what? From minus infinity to infinity. We don't have an issue. For A, you have to exclude the 0 of the denominator. You have to solve 3x plus 1 equals to 0 and exclude it from the real numbers. For K, you have to solve x plus 3 greater or equal to 0. All right. Now they're asking us to, it's like a review or, extra exercises. What is f of minus 3? For this function, what is f of minus 3? What is the image of x equals to minus 3? What? Minus 3, yes. Minus 3. Why? Where is x equals to minus 3? This is x equals minus 3. This is the line x equals minus 3, right? It intersects the curve at y equals minus 3. So this is minus 3. What is f of 0? 2. Excellent. Yes, 2. This red line intersects the function at this point, which is 2. Okay, now they're doing they ask us in a reverse matter. They have the image and they want us to find the values of x. So which value corresponds to y equals to minus 1? Which x mapped into minus 1? Let's see. This is minus 1. Y equals minus 1. Yes, it intersects the curve at x equals minus 1. What about f of x equals to 1?
3.
Not 3.
2.
2. Yes, 2. You see? This is y equals 1, right? Which intersect the curve at this point. At this point. So x in this case is what? Is 2. Going back a little bit. What about f of minus 1? Oh, I'm sorry. What is f of minus 1? Minus 1. F of minus 1 is minus 1. See? This line intersects the function at here. And this point, the y at this point is minus 1. What if I ask you to find all x such that f of x equals to 0? find all x for which of x equals to 0.
Will be 1 or minus 1.
1 and minus 1, 2. So which values is mapped to into what? Into 0. Into y equals 0. This is y equals 0. Nothing. There's no x has what? An image equals to 0. Y equals 0 does not what? Intersect the curve f. Therefore, find all x for which f of x equals 0, none. All right, no, the same, they're using the same graph and asking us about what? About the x-intercept and y-intercept. What's the x-intercept of this function?
0.
What do you mean by 0? X equals 0, you mean?
Yes, because it's not cutting with it.
So none, you mean?
No.
None. Not 0. 0 is a number, right? So none. This function does not have any what? Any x-intercept, because this function does not intersect x-axis. Okay, determine the y-intercept.
0.
2.
This one.
Just 2. You write 2. Okay, using the same graph again. What is the domain and the range of this function?
The domain is from minus infinity to infinity.
Correct, yes. From minus infinity to infinity. Why? Just keep this. Nothing will happen except at 0, at minus 1. Minus 1 is also included. Why? Because we intersect the function at this point. And keep rolling. So from minus infinity to infinity represent what? The domain. Now, what about the range?
Minus infinity to minus 1.
Minus infinity to minus 1. That's it?
No, then
3 will be minus infinity.
So minus infinity to minus 1. You're right. So extend this. You will keep intersecting the, right?
Yes.
Keep intersecting this curve till minus 1. And minus 1 is included because of this. Then we have another segment for the range.
And
Now we'll stop intersecting the curve, right? We'll stop intersecting the curve, but going back after a little bit. At what? At y equals 1.
1 to
Yes, y equals 1 is included again. But why? Because of this. Then you see these. Extend this. Yes, you'll keep intersecting the function. So from minus infinity to minus 1 and from 1 to infinity. And of course, you can do this example as a self homework. All right, I'm not going to a new topic.